post-apocalyptic drying. Oh, no, wait. That was the movie that I just watched. Never mind. Okay, post-chromographic drying. All right, well, this idea is, okay, after I go through the development, and I got 3 choices of development. Remember what they were? I got, unsaturated. So the unsaturated tank is just me plopping it all in, putting a lid on it, and saying, I don't care. I'm going to do what I want to do. Bye. And then I just leave and go to lunch and then come back and then argue about the bagel people. And then when I do that, okay, well, that guy is, his feelings is hurt. But you probably don't care, do you? You'll still go back and get them. All right, so next up, the unsaturated is put it in, put a lid on it, let it go. Great, good. Okay, so that seems like it would save some time. It does, but you don't get reproducible results as much with that. So we very often do not do a unsaturated twin trough chamber. Remember TCC, twin trough chamber, it's probably going to be a Canvas question. Next up is saturated plates. So the saturated plate is the idea, or saturation method, is the idea that I'm putting a pad in, I'm putting developing solvent in, it's filling up the gas phase, it's in the upper realms of the chamber, and that way when I put the plate in, it is ready to go. HOTTOGO. Okay, so the saturation idea is probably the most common as far as we go when we develop these plates in some type of instrumentation. So the gas phase is there, the gas phase is ready. Developing solvent is now more appropriately the mobile phase. We put the plate in after a 20-minute wait time, and then our separation begins to happen. Preconditioning is slightly different. What happens in the preconditioning moment is that I only utilize one of the troughs. I put the developing solvent in that trough. I allow that to generate the gas phase just like we did in the saturation step. Once the gas phase is being generated, and again, we give it like 20 minutes, I then put the plates down into the empty chamber or an empty trough of the chamber. So no development is taking place. The plate's not sucking up anything at all, but we're giving it kind of like a head start. So we're allowing the gas phase to latch on to the silica or to the stationary phase for about 10 minutes. And then if we do that, we're allowing that plate to saturate. We're allowing that gas phase to kind of do what it needs to do, find its home, find its spot, find where it needs to belong. So that way, when we do put developing solvent in that empty trough, that plate is going to suck that up, and it's going to suck it up maybe better in more of a reproducible type of environment. We've got more control of it, but it's also an extra 10 minutes. So there are times that we do not need this. Saturation seems to be, I would say, the more appropriate type of separation that we will do in our lab, but I'm not saying that this is not common in real life. I'm just saying that with what we will do with our instrumentation from the KMAG system, we like the saturated type of developments, and that's what you'll see more of. All right. So now I want to talk about the concept of drying. So however which way it develops and whichever way it needs to do that, it's going to do it. And then after that, my little instrument is going to go and then it's going to let me know that it is now finished. It's now ready. I need to do something with it. Absolutely. So now I'm going to get the plate out of the thing. No, not really. So normally what happens here is that after it has been developed, you are going to take it out from the chamber. Absolutely. You'll do this manually if you don't have a piece of instrumentation to do it for you, and that's okay. Or the machine is going to raise it up out of the chamber for you. It does not allow it to expose any more time in there. So it's going to take it out and it's going to seal the chamber back off, so that way your plate is not exposed to that mobile phase or developing solvent or the gas phase any longer. All right, so normally what the next step is that you're going to have to That's what that is. So that's a hair dryer. That's my hair dryer noise. Wasn't that pretty good? So you're going to take a hair dryer to it if you were doing it by hand, or the developing chamber will also do it as well. So if you were in the developing chamber and the machine was like, oh, okay, I'm done. Now I'm going to take the plate out, and it takes the plate out and it holds it up and dangles it in midair. No, it doesn't really dangle it in midair. It kind of does, but not quite. What you're going to see is you're going to hear a noise, and that noise is going to be a dryer system that is going to basically take some warm hot air, and it's just going to help that mobile phase to evaporate on off. If you do not get that mobile phase off, then what's going to happen is that your separation is still going to continue. So I need that mobile phase off of there as quick as possible, because as long as it's coming in contact with my sample, as long as it's coming in contact with the stationary phase, it can still creep up and up and up and up and up. Wasn't that a song, Creep? Okay, yeah, I think it was. If not, you need to listen to it. All right, so I need to get that mobile phase off of there, and then that's going to kind of help do that process a little bit faster, a little bit easier. And again, it can just be a normal hair dryer that I use at the house if that's what I want to bring into the lab to dry my plates off. So this is not going to require a very lengthy type of drying process. We're talking at just like really a handful of minutes, not very many at all. So that is the normal kind of common process here. Please do not forget that. I think that when people do that by hand, they don't do it, and then they wonder why maybe their spots are a little smeary, or the bands are maybe a little too wide, or why theirs kind of changed, or maybe didn't match with the RFs of someone that has done this over and over and over. And it is one of the reasons that, you know, we have differences in RF values if we are especially doing some hand development procedures here. So they're very often dried. Hair dryers are pretty common. You can put them in the oven. I mean, that's okay too. But if you put them in the oven, just keep an eye on them. Make sure the oven is set at an appropriate temperature. You don't want to overheat the plates because you can damage them if you're not very careful, or char or burn things that might be on the plate itself. So you just got to really know kind of what is there on the plate for you to do that. But an oven is okay if that's the only option that you've got. Also, please do not forget to mark the solvent front. Please, 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 please. You want to mark that with a pencil. So if you are developing these by hand, as soon as you take out the plate, I think that people listen to this lecture and like, where's the hair dryer? Where's the hair dryer? I got to get rid of it. I got to get rid of it. Okay, well, before you do that, you want to take a pencil and mark where that mobile phase line went. You've got to mark it all the way across. Do not only mark it at the edges of the plate. So, for instance, if you take a plate out and my plate has developed, why on earth would you mark it just here and there? And the reason that I say that is because you don't quite know what's happening in the middle. Are you even paying attention to what's happening in the middle? Because if you do not mark this solvent line all the way across, if you are doing this by hand, then you could actually run the risk into mobile phase kind of doing this on the plate. And you're going to assume that the mobile phase line is the same all the way across the plate. And it might not be. It actually might be different all the way across. And it's because you are just suggesting the idea that the developing solvent is going to go up the plate and it's going to be consistent all the way across. And sometimes that happens and sometimes it does not. So when you take the plate out, you better take a pencil and you better mark the solvent line all the way across the plate at the very top. If you do not, you run the risk in calculating an incorrect RF value, because you should have been doing a spot difference between there to here maybe, and then you should have done a mobile phase length from there to there, not there to up here, which is where you would have marked it if you just made the assumption that it was all even all the way across. Please do not fall for that trap. It's also one of the reasons that if I'm spotting maybe knowns that are standards, and then if I begin to spot unknowns, they don't quite actually perfectly match. And you're like, well, it doesn't perfectly match, but is it that thing or is it not? My RFs are different, and you told me that RFs have to be the same. What am I going to do? Do I got to do it over? No, what's happened here, maybe, is the idea that mobile phase went differently as it traveled up the plate. And those are slightly different lengths that you need to divide by at the bottom. And those slightly different lengths are going to equate to different RF numbers for you in the very end. So please mark it all the way across. Trace it exactly where it is when you take the plate out. The instrumentation has a little more control. The instrumentation does, for the most part, have a very level mobile phase line all the way across the top. And it will actually do a pretty good job calculating the RFs for you based on what it sees. But if we're doing it by hand, we got to rely on ourselves a little bit more. So that is why we mark the lines actually all the way across once we immediately take the plate out of the chamber. And then at that moment, you can take a hairdryer to it or place it in the oven and get rid of that mobile phase as soon as you can. We want that gone, so that way separation does not continue to happen over the course of the time period. That we just allow it to sit there and watch it like grass growing. Oh, that was awfully painful. And I don't want to sit there and watch grass grow. So why would you sit there and watch a plate slowly evaporate the mobile phase off? Again, does not make any sense. Warm it, heat it, get rid of it, stop the separation, and that is done by getting rid of that mobile phase. All right, so that's going to kind of stop, I guess, the lecture video. I'm kind of short. Oh, gosh, look at me. I must be feeling ill. I'm coming down with something. All right, well, I think that because of what I'm getting ready to say, it somewhat makes sense, because in the upcoming video, we're going to start new information, and that new information is going to be really focused on the next assignment that we will see within our online variety pack of things that I've got to do if I want an A in the course. So in the next one, we'll start material with the new assignment, and I'll see you then. Enjoy!